A study is carried out in a landfill in Saitama Prefecture, Japan, where a layer of soil, approximately 2.5 meters thick, is used. The purpose of the proposed study is to investigate the role played by waste dumps and their production of greenhouse gases in climate change, taking as a reference the final compacted soil cover, which has a fundamental function in transport and the final point of the gases emitted by landfills.
The study developed in the article investigated the effects of dry bulk density and particle size fraction on soil gas transport parameters, soil gas diffusivity, ratio of gas diffusion, coefficients in soil and air free, and air permeability under different humidity and saturation conditions. For this, compaction tests were carried out of the soil samples using three different methods: standard and modified Proctor compactions and manual compactions, where the bulk density was between 1.40 and 2.10 cubic centimeters. The results showed a relationship with the size of the gravel fraction, finding that the plus gravel fraction, less than 35 mm, has higher values of soil gas diffusivity and air permeability, due to the fact that it has a larger network of macropores than the minus gravel fraction, less than 2 mm, in variable humidity conditions.
The analysis procedure is explained in the following order. After taking the soil samples, they are sieved through a 35 mm mesh in the laboratory to eliminate the largest fractions. Next, part of the samples is sieved again through a 2 mm mesh to separate the plus gravel and the minus gravel fractions. Compaction is carried out after distributing the particle size for each sample with the previous methods: standard and modified Proctor and manual. They are saturated with water and some samples are drained or dried, repeating compaction methods and measuring their relative humidity and gas transport parameters in determined periods. The result established that the apparent density in plus gravel fractions is greater than in minus gravel fractions in similar air-filled pore sites. Here we suggest that this is due to the compaction of well-aligned macropores that are ready for gas transport through the porous material, independently illustrating the results thanks to the application of the model described therein.